All right, so in 4.2, we're going to start with the triangle angle sum theorem, right? And this you guys already know, and we've been using it really in the other chapters too. The sum of the measures of the angles in a triangle is what? 180. So the way we write that is measure of angle A plus measure of angle B plus measure of angle C is 180. Never A plus B plus C is 180. Okay? All right, so let's prove the triangle sum theorem. Since you were little, we've just told you, hey, all the angles add up to 180, right? But we've never really proven it to you. And nobody's ever asked, hey, Miss So-and-so, just can you prove that? Well, here we go. Oh, well, because it wasn't time. Now is time. Right? Now it's the time. Okay. So you're given triangle PQR, and you're given that line PS and line QR or RQ are parallel to each other, right? So normally, we weren't given these two. We had to do it ourselves. Now, we're making it simpler for everyone. This is called an auxiliary line. We've kind of heard it before, right? You draw it in order for it to help you in the theorem, okay? So we have to prove measure of angle 1, 2, and 3 add up to 180. So that's the given. Now, measure of angle 4 plus measure of angle RPS, this one, okay, equal 180. What would be the reason there? They're linear. They are a linear pair. So what's the theorem? Supplement theorem. Okay. All right. So those two are equal to 180 together. Measure of angle RPS is equal to, so this is measure of angle RPS, is equal to measure of angle 1 plus measure of angle 5. And what is that? Say it again. Angle addition postulate. So, measure of angle 4 plus RPS is 180. RPS is measure of angle 1 plus measure of angle 5. And now I can combine them, right? I can say measure of angle 4 plus what was RPS? 1 plus 5. So measure of angle 4 plus 1 plus 5 is 180. What is that? Substitution, exactly. No, substitution, because you're not saying one is equal to the other and the other is equal to the next, right? Now, here we go. Angle 4 is congruent to angle 2. What types of angles are those? Alternate interior angles theorem, and also 5 and 3. Now, next. Measure of angle 4 is equal to measure of angle 2. Measure of angle 5 is equal to measure of angle 3. So here, look at what we're doing here. Here, we were saying measure of angle 4 plus 1 plus 5 equals 180. Okay? Here we said the two angles are congruent. In order for you to use this congruence in another statement that calls for the measures to be equal, right? This is equality, this is congruence. In order for you to be able to use this in an equality statement, you first have to transfer this to an equality statement. So this is the definition of congruent angles. Good. And now, look at this again. Whoops, just this. 4 plus 1 plus 5 equals 180. But we said measure of angle 4 equals to measure of angle 2. So now this, I'm going to make it measure of angle 2 plus measure of angle 1. and I said measure of angle 5 is equal to measure of angle 3, right? So I'm substituting, and, well, that's what it is. It's substitution. So I've proven now that measure of angle 2 plus measure of angle 1 plus measure of angle 3 equals 180. Okay? All right. So, good.
So we didn't even use the new proof of it.
So we're proving the new proof. We're proving the new theorem, right? Because you've always told to blindly accept that measure of angle 2 plus 1 plus 3 equals 180, right? And now we proved it and we said, oh, look, it does equal 180. Okay, and now that we've proved it and we've introduced it, you can use that as a theorem anywhere else. Yes?
Can you prove it by using a protractor?
That's not proving, that's illustrating. And there is a difference. Yeah. Okay. A proof is a much more formal way to show something that relies on other mathematical statements, facts, definitions, theorems, postulates, and so on.
How would it be proven without the lines?
How would it can't.
Oh, okay.
But before you weren't given the lines, so you had to do them yourself and said, blah, blah, blah. Okay, so find the missing angle measures. So here we go. We're going to find the missing angle measures. So here, what do we know? Measure of angle 1, right? Measure of angle 1 plus 28 plus 82 is 180, right? So what's measure of angle 1? It's 70. Fabulous. 2 is a vertical angle, so it has to also be 70. And if that's 70, then measure of angle 3 plus measure of, plus 70 plus 68 is 180. So it's how much, Clara?
I have it right.
Yeah, you were.
42.
42, yep. Okay? All right. Questions? Okay, so take a look at this one. Where would we start? Yep, Owen.
Angle 1 in 57 is a linear pair, so 257 minus 180, which is 127, I think.
23. 123. Good. So measure of angle 1 is 123. Don't you love it when it turns out to be 1, 2, 3? Grayson?
Sorry, 2 is 52 degrees, because 71 plus 57. So it's 120 degrees.
Right. Measure of angle 2 plus 57 plus 71 equal 180. So measure of angle 2 is 52. Yeah. And then, so 123 and 28 equals how much? 151? So how much is left over for measure of angle 3? 29. Look at you guys go. Okay. All right. So let's talk about an exterior angle, right? Huh? 123 plus 20 is 143, plus 8, 151.
Then you do 180 minus 151.
And then you do 180 minus that. Yeah, so those two are 151, and that leaves 29 to make it 180. Okay, so look at this triangle here, right? You see this yellow triangle, or, the yellow. So that, right, the shaded part inside the triangle is called the interior of the triangle. All right? And obviously, everything else is the exterior. So look, if I were to take any triangle and if I were to extend any of the sides, what I make here is called an exterior triangle, right? So if you take any old triangle, extend one side, you make an angle there. We'll call it angle 1. Now let's extend the other side. That's a second one. Now let's extend the other side. That's a third one. Okay? Those are called the 1, 2, 3 outside. These are called exterior angles. And here, right, here you have 1, 2, 3 inside. You see the 4 is an exterior angle. Okay? Now, take a look at that 4. All right? You have 3 interior angles, correct? Which of the 3 interior angles are farthest from here? Which 2 are farthest from 4? 1 and 3. What's another word for far? Or remote, right? So these are called the remote interior angles. That's what we call them. Remote interior angles. Okay? So that's an exterior angle. Another diagram here, right? You have an exterior angle here. These 2 are the angles in the inside of the triangle that are farthest away. They're called the remote interior angles. The other one is just adjacent, right? So you should know that term, remote exterior angles. Sorry, huh?
It's interior, not.
Remote interior angles.
Right, there's no exterior.
Well, angle 1 is the exterior angle.
No, like there's no remote exterior.
No,
Okay.
it corresponds to remote interior angles. And the reason why you need to know that term is because it's got a theorem. Okay, so here is the exterior angle theorem. The measure of an exterior angle of a triangle is, the measure of an exterior angle of a triangle, so for example here, angle number 1, is equal to the sum of the measures of the 2 remote interior angles. So the measure of angle 1 has to equal the measure of 2 plus 3. Okay? So for example, suppose this is 30 and this is 70. How big is measure of angle 1? 80. Is it? No. It's equal to the sum of it's 100. Okay, measure of angle 1 is 100. Okay, does that make sense to you? How much is this remaining one? 80, right? So that has to be the other, like, supplement. Okay?
Wait, what?
I'm so lost.
Okay, so let's do that again. Suppose you have this angle is 30 degrees and this angle is 70 degrees. Okay, now look at angle 1 here, right? Is that an interior or an exterior angle? That's an exterior angle. The measure of angle 1 is equal to the sum of the 2 remote interior angles. So you add these up, what is it equal to? 100. So this is equal to 100 degrees. Okay?
So the exterior angle is equal to the 2 remote?
Yes, the sum of the 2 remote, right? The measure of an exterior angle is equal to the sum of the 2 remote interior angles. Okay, now we're going to prove it. We're going to prove that that angle is always going to be the sum of these 2. Okay, do you believe that? Like, just on your own, do you believe it?
Yeah, because it says.
Well, yeah, but also why not? That's what I was trying to do before. Is so if inside the triangle, if this is 30 and 70,
Well,
then how much is this?
Well, it's
80.
linear pairs.
Right. So this is 80, right? So just like this and these together add up to 180, this and this have to add up to 180. Okay? All right. So you're given triangle ABC. All right. What is?
Doesn't make. I don't understand what it's saying.
A linear pair has to be 180 degrees, right? A triangle has to be 180 degrees, right?
Okay, we'll come back to it. So let's try to prove this. Okay? All right. So this is the given. So we're given triangle ABC and line AD. Okay? So what do we know? We need to prove that CBD is equal to measure of angle A plus measure of angle C. Okay, well, what do I know about the triangles inside, the angles inside the triangle? I know that measure of angle A plus measure of angle C plus measure of angle ABC equal to 180, right?
Why couldn't you just say measure of angle A plus measure of angle B plus measure of angle C?
Because if I say measure of angle B, that could mean two angles. I need to specify. Okay, angle B could be this one or this one. Because it's split, I need to specify. So that's the triangle sum theorem. Okay? Number 3, measure of angle CBD. Okay, so take a look. Measure of angle CBD plus measure of angle ABC equal to what? 180, right? Do you also see how this and this equal 180? Yeah, what is that? That's the supplement theorem. Okay, so if this equals to 180 and this equals to 180, that means they are equal to each other. So measure of angle A plus measure of angle C plus measure of angle ABC equal to measure of angle CBD plus measure of angle ABC. What is the reason for that? Substitution. Next, look, I have measure of angle ABC on both sides, so I can subtract ABC. I can subtract ABC. Okay, what do I have left over? Measure of angle A plus measure of angle C is equal to measure of angle CBD. Subtraction. All right? Okay. Any other questions? I was debating that. You know what? It's okay. But thank you for being conscious of that. Oh, what happened? Huh? Yeah, okay, let's go ahead and flip it. So measure of angle CBD, it's good practice, equals measure of angle A plus measure of angle C. What is that called? Good for you, symmetric property. Okay, good. All right. All right. Oh, look at these. I love these problems. Okay. So look, measure of angle 1, right? We need to find measure of angle 1. So look, do you see how when you have this as a triangle and you extend one of the sides, do you see how measure of angle 1 is an exterior angle? It's an exterior angle. It equals to the sum of the two remote interior angles. So that's 50 plus 78, 128. Okay. Measure of angle 2, right? How much is measure of angle 2? Why?
I'm sorry, 180 minus 180.
Right. Together, this is a linear pair. So that's 180 minus 128, 68. Oh, sorry, that was measure of angle 2. I'm sorry. Here, up here. 180 minus 128, 52. I'm sorry. Okay, measure of angle 3. Here. All right, so we said 2 was 52. So look, do you see how this is a triangle? Let me erase some of these. Do you see how this is a triangle? And if I extend this side, is the 120 an exterior angle? The 120 equals to the sum of 2 and 3. So 120 minus 52 is 68. Oh, good for you.
Thanks.
See? Now, measure of angle 4, look, that's a linear pair, 60.
60 plus 56 is 116.
Yep. So look, another triangle. Extend one of the sides, that's an exterior angle. It's
Just do 16 plus 56 and then that minus 20.
right, and this is a more direct way of exactly that. Okay? So 60 plus 56, 116.
I don't understand how you got from measure of angle 3.
Measure of angle 3. Okay, so this 128, this one, the yellow, is an exterior angle. Oh no, is that the way we did it? Sorry. We were here then. This 120 is an exterior angle. Okay? It equals to the sum of the two remote interior angles. So we knew that this was 52. 120 minus 52 is 68. Because these two together add up to 120.
What?
Look at that, just that blue triangle. Okay? This 120 is an exterior angle. It equals the sum of the two remote interior angles. So it equals 2 and 3 summed up.
Oh, so 50, got it.
Right, okay. So let's move on. Find the measure of each angle here. So measure of angle 1 is how much?
55.
55.
Why 55?
Because
Go ahead, Clara, go ahead.
Because you do 180 minus 23 plus 32, and you get 125, and 180 minus 125 is 55.
Right, so that's the extended way. Exactly, that is the extended way of recognizing that that's an exterior angle, meaning it's the sum of these two, 55. But that's exactly how we proved it, right? Because that and that is 180, and then you subtract. So that rather than doing the two subtracting or whatever, that's the more direct way. So angle 1 is 55. Okay? 55 is an exterior angle, right? 55 is an exterior angle, and it's the sum of 2 and 22. So measure of angle,
So 55 minus 22.
right, measure of angle 2 plus 22 equals 55. So measure of angle 2 is 33. And if that's 33, the other one is 180 minus 33, 147. Okay? All right. So we've talked about postulates. We've talked about theorems. Next, a corollary.
Oh, bless you.
A corollary is a statement that can be easily proven using a theorem. Usually, a corollary is something that follows from a theorem, okay? So for example, like somebody will tell you a theorem and you'll be like, oh, so that means angle 1 and angle 2 are always congruent. That's a corollary. So here we go. Corollary. The acute angles of a right triangle are, so the acute angles, this and this, of a right triangle, they always add up to how much? Nope, just the acute ones. Just these two blue ones. They always add up to 90, so they're complementary. You see how this is so basically we know that the three of them together add up to 180. So now you're like, oh, so then if one is 90, then the other one have to be complementary. Can you guys sit up, please? Thank you. Here we go, another one. There can be at most how many right or obtuse angles in a triangle? We talked about this yesterday.
1.
1. It's kind of a giveaway because the the object is singular, right? All right, so let's find each measure in angle DEF. Okay, so angle 1, let's get in the habit of, not doing, 180 minus. Let's just get in the habit of just doing 90 minus 25, 65. Okay? We just said, remember, that if you have a right triangle, the other two are complementary.
Right.
So 90 minus 25 is 65.
Oh.
Okay, so in the other triangle, this is 90 again. Okay? So the acute angles are 65 and 2. So 90 minus 65 is 25. Okay? So I do want you guys to get in the habit of doing that. Okay. In triangle MNO, M is equal to N, O is blah, blah, blah. Okay, I already lost what the problem is saying because I have no way to visualize it. So I stop and I say, you know what? Let me just draw this triangle, MNO. That should be your first step. Triangle and label. Start with one vertex and then go around. So now, okay, angle M is equal to angle N. Okay? O is 5 more than 3 times N. Whoa, okay. So why don't we call this X? All right? Yeah.
So I'm thinking O is 3x plus 5.
3x plus 5. 5 more than 3 times N. When I was your age and taking geometry, after I did this, I'd be like, okay, let me read it again. O is 5 more than 3 times N. Yep, that's good. Okay? So now you want to find each angle. So, all right, X plus another X plus 3x plus 5 equal to 180. Don't forget about that other X. So 5x plus 5 equals 180. 5x is 175. X is 35. Are we done?
No.
Nope, that's halfway. So now you've gotten half of the points of the problem, right? So measure of angle M is 35. Measure of angle N is 35. Measure of angle O is 3 times 35 plus 5, how much? 110. Okay? All right. Find the values of A and B. Okay. So look, 2 things here. First, what type of angle is this? Exterior angle. What is it equal to the sum of? It's equal to the sum of which 2 angles? The 2 remote interior angles, these 2. Right, so A plus 10 plus B plus 6 is equal to 3A plus 8. Okay, let's simplify that a little bit. Let's see what we got here. A plus B plus 16 equals 3A plus 8. So let's see, I'm going to subtract 8. So 8 is equal to, and then I'm going to move everything to the other side. So let's see, A plus B plus 8 is 3A, minus A, minus A, minus B, minus B. So 8 is 2A minus B. Well, now we have A and B in the same equation, but is there another relationship between these angles that we missed?
1A equals B plus 10 plus 3A plus 8.
B plus 10. Well, okay, so that's another thing you can do. Yes, B plus 10 plus 3A plus 8 equals to 180. Good. These 2 equal to 180 together because it's a linear pair.
A plus
And
10 plus B plus 6 plus B plus 10 equals 180.
Right, also all three of them together equal 180. So here we go. 3a plus b is equal to 162. So now I have these two. So I have 3a plus b is equal to 162. 2a minus b is equal to 8. Okay? Remember when you did systems of equations in Algebra 1? Did you guys do that in Algebra 1?
I think so.
So now we're going to add these two. So you add by columns. 3a plus 2a is 5a. b plus negative b goes away. Equals 170. A is 34. Okay? How do I find b?
You plug it in.
Plug it into one of the other ones. So 3 times 34 plus b is 162. So 102 plus b is 162. B is 60. Okay? There we go. Yes? Yes.
Any expression